Okay, so we're back with the second part of this section. We're still going to talk about the exact same procedure. I just want to show you another example. So our example this time for solving a polynomial function using the rational zero theorem looks like this. So directions are the same. Find the zeros and factor. Okay, and notice that our polynomial is fifth degree. All right, the highest exponent is 5. Okay, which means that we would expect to have 5 zeros when we're done. Okay, all right, so let's go ahead and get started. All right, I'm just going to write down that we expect 5 zeros, so we kind of keep that in mind. All right, so let's do our rational zero theorem. So remember that the p-value is going to be the last number. You're specifically looking at the number that doesn't have an x beside it. All right, so this is going to be the p down here. And the q is the first number, assuming that things are in order. It's going to be the number in front of the x, the highest power of x. All right, so I'm going to go ahead and just kind of jot this down. So we have p is equal to -8 and q is equal to 3. And then we want to write the different factors for each one, the different ways that we can multiply numbers together to make 8 and 3. So I'm going to simplify a little bit as I go. I know that for 8, I can do plus or minus 1 and plus or minus 8, because I know 1 times 8 is some combination of that would give me 8. And I also know that 2 times 4 would be another way to make 8. So I'm going to do plus or minus 2, plus or minus 4. And I'm just kind of trying to get them in order as I write them down. All right, for the 3, the only way that I can multiply numbers together to make 3 is 1 times 3. All right, so I'm going to do plus or minus 1, plus or minus 3. All right, so the next thing that we're going to do, remember, is that we're going to write fractions. So we're going to do p over q. We're going to do all of our p values over the 1 first. Okay, so nothing's going to change when I do that. 1 over 1 is still 1. 2 over 1 is still 2. 4 over 1 is 4. 8 over 1 is 8. All right, and then I'm going to take my numbers and I'm going to put them over 3. So I have 1/3. I have 2 over 3, which would be 2/3. 4 over 3 would be 4/3. And 8 over 3 would be 8/3. Okay, so this right here is going to be the list of possible rational zeros. So remember that what this theorem says is that if this function has a rational zero, that it's going to be in this list. So it kind of narrows it down. Now we still have 1, 2, 3, 4, 5, 6, 7, 8. We still have 16 numbers in the list, but at least we don't have an infinite number. Okay, so it has narrowed it down to these 16 numbers, and it's basically saying if this function has a rational zero, it is in the list. So I'm just going to note that these are our possible rational zeros. All right, so remember that the thing that we did next was we just sort of randomly picked one of these numbers and plugged it into the function, checking to see whether we got 0 or not, okay? Now, because this is a 5th degree polynomial, we really need to find 3 zeros, because remember, with every 0 that we find, the power reduces by 1. So when we find the first 0 and we do synthetic division, we're going to be at an x to the 4th. We still can't solve an x to the 4th. So we're going to have to find another one. That's going to take me to an x to the 3rd. Still can't really solve an x to the 3rd. I'm going to find a third 0. That's going to take me to an x squared, which I can work with. Okay, so my goal is to do this guess and check and find 3 zeros. Now, I'm going to go ahead and say to you that if you have a graphing calculator, that you're using for the course, then graphing this function would probably be a good idea. And we'll look at this in a little more detail in the next example that I do. But if you'll graph the function, you at least know, you can look at the picture on your calculator and know what might be a good guess to make from those 16 numbers. Okay, so I'm going to try x is equal to 2 as my first number. Okay, so I'm going to say, let's suppose that x is equal to 2. Okay, to check it, remember that you're going to take your function and you're going to plug a 2 in everywhere there's an x. This is kind of a long function, but we're going to go to the calculator with it anyway. All right, and when you do put that in the calculator, you will see that you do get 0. And so that tells you that that was a good choice to make, that you found one of the zeros. So if you've got a list going somewhere where you are writing out the zeros for the function, you can go ahead and put that in the list. X is equal to 2 is one of those zeros. All right, I'm also going to try -2. Okay, now again, I'm looking at a graph, so I'm trying to make some smart choices. I can tell from my graph that, for example, it doesn't look like there's a 0 at 8. Okay, it doesn't look like the graph crosses the x-axis at 8. All right, so I am trying to be smart so that I don't have to check all 16 of these numbers to find the 3 that I want. If you don't have access to a graphing calculator, we're going to talk about some ways to do this in a little bit that are a little more efficient. But for right now, you're simply going to have to take a number and plug it in and see, does it equal 0 or does it not? Okay, if it equals 0, then you got lucky and you found one that works. If it doesn't equal 0, then you start over with a different number. There are apps. If you don't have a graphing calculator, there are apps for your phone that you can download and use those kind of as a graphing calculator. All right, so that might be something to try just to help out just a little bit. All right, so that's also equal to 0, so that one is also a good choice. I'm going to go ahead and put it in my list up here. -2 is a 0. Okay, and then the third one that I'm going to check is -1. And again, I'm going to take my function, and everywhere there's an x, I'm going to put a -1. All right, and when I take a second and plug that in my calculator, I can see that this is also equal to 0. And so that is my third 0 that I needed. Okay, remember you need to find 3 of them because the polynomial is a 5th degree. And once we do our synthetic division, if we have 3, we'll be down to a squared term that we can actually solve for the other 2. Okay, so now let's do the synthetic division. Okay, so I'm going to start with the 2. And I'm going to put these numbers from the original function underneath. All right, so I have 3, -2, -15, +10, +12, -8. All right, so we're going to go through our synthetic division. We're going to drop that 3 down and get started. So 2 times 3 is 6. We'll add and get 4. 2 times 4 is 8. We'll add and get -7. 2 times -7 is -14. We'll add and get -4. 2 times -4 is -8. We'll add and get +4. 2 times 4 is 8. We'll add and we'll get 0. And again, the expectation is that you do get 0 because you've already checked it. You already know that that's what's fixing to happen. Okay, let's move on to the next 0. Now, this is important. When you move to the second zero, you don't want to go back to the original function. What you want to do is go to where you left off on the previous synthetic division, because you want this thing to get easier each time. If you constantly plug it back into the original, it doesn't get any better for you. Okay, so plug in to where you left off in the previous synthetic division. It should be one step shorter. All right, so we're going to drop the 3. Negative 2 times 3, negative 6. We add and get negative 2. Negative 2 times negative 2 is 4. We add and get negative 3. Negative 2 times negative 3 is 6. We add and get 2. Negative 2 times 2 is negative 4. We add and get 0. All right, so again, that's what we expected to have happen. Okay, so now we're going to take the last 0, which is a negative 1, and we're going to plug it in again to where we left off. So we've got the 3, the negative 2, the negative 3, and the 2. So we're going to drop that 3 down. Negative 1 times 3 is negative 3, and we'll add. Negative 1 times negative 5 is positive 5, and we'll add. Negative 1 times 2 is negative 2, and we'll add. All right, so finally what we're going to do is put the x's back into the answer. So remember that we had an x to the 5th. We've gone through it 3 times. So this part becomes x to the 4th, this part becomes x to the 3rd, this part becomes x squared. So our answer is 3x squared minus 5x plus 2. So it's a quadratic. I should be able to factor it. Now I'm going to have to find a little room, so I'm going to come up here and see if I can get that to factor real quick. So 3x squared is going to be a 3x and an x. The 2 is going to be 1 times 2. We need our larger term to be negative. All right, so think about the zeros that are going to come out of these last 2 factors. All right, we know that we're going to get a 2 out of the x minus 2 when we set that equal to 0. Sorry, I'm really running out of room here. So we know that we've got x is equal to 2 as one of those zeros. All right, and then we also know okay, hold on just a second. I am double checking myself. All right, so let's see something just for a second. I don't have it factored correctly, do I? All right, so let me try again on the factoring. I'm going to erase here. Sorry, guys. All right, so let's get rid of that. Let's come back over here. Let me try to factor this again. Hopefully, if you had been in class sitting with me, you would have said, hey, you factored that wrong, and we'd have caught it right there. All right, so let me try again. So 3x squared, we would have 3x and x. And then for the 2, I would need a 2 and a 1. So I'm going to put the 2 right here and the 1 right here. And I need that 2 to be positive. So either they both have to be negative or they both have to be positive. Because I'm trying to get out a negative 5, I'm going to make them both negative. Okay, so I'm going to do a quick FOIL and just make sure. So 3x squared minus 3x minus 2x plus 2. Okay, so I think I have it now. All right, so I'm going to take each of those terms. I'm going to set it equal to 0 and solve. So minus 2, we're going to add 2 to both sides. 3x is equal to 2. We're going to divide both sides by 3. All right, so that gives me a 0 at 2/3. So I'll put that in my list over here. All right, and then the last one, x minus 1 equal to 0. We'll add 1 to both sides. That's going to be x is equal to 1. All right, so that looks better. We have all 5 of our zeros. Okay, and then the last thing that we need to do is factor this polynomial. So I'm going to do that with you real quick. Let's get rid of some of this so we have some space. All right, so factoring the polynomial, we already have 2 of the factors. Remember, these 2 are already done, so we can go ahead and put those in. So 3x minus 2, x minus 1. Okay, now I need a factor for positive 2. Remember that you're going to do the opposite number in sides. That's going to be x minus 2. I need a factor for negative 2. That's going to be x plus 2. And I need a factor for negative 1. That's going to be x plus 1. All right, so now we have the polynomial completely factored, and we have a list of all of our zeros. Okay, so again, I'm going to stop this right here, post this one, and I'm going to come back and do one more example just to give you one more exposure to a different type of problem.